Hi, I'm Risha, the lead of hardware and CAD, or computer design. Today, we'll be discussing the build of our robot, as well as talking about what are chassis and mechanisms. Even though our team is competing virtually, we still use whatever would be best in more of a competitive setting. Anything from maneuver, omnidirectional movement, or how effective it would be if we were competing in an in-person setting. First, it's a chassis. Think about it as the base or supporting frame for a robot. Everything you will need will be added on top of it. Here is the chassis build for a robot. We use the Strapper Kit version 2 from GoBuilder. Coming from the point of view of building a chassis in FTC, the main things that will be attached onto the chassis are the wheels. Now, the wheels our team is using are Mecanum wheels. They have many perks that can help us drastically in this game. Other than that, we also attach the control hub and expansion hub from Rev, as well as a battery. Now, once you have built your chassis, you always want to start programming it from there. This way, it'll be easier to fix any mistakes on the hardware end, since adding mechanisms after can cause some trouble when fixing the chassis. When building a chassis, it's always important to make sure everything is tight. You can easily detect loose items when driving. This can cause multiple troubles when playing the game. Always try to have a chassis as symmetrical as possible. Weight might be a problem. Always try to balance the weight as much as you can when building. Next are mechanisms. Mechanisms are built to get a task done, from gripping objects, lifting up, and launching objects. Mechanisms can vary based on what your task is. When building mechanisms, try to always use what you have to build off of. For example, if you were making a launcher mechanism, use a stand to make room and add other mechanisms. For our game this year, the tasks are collecting rings, launching rings, lifting a wobble, dropping rings, and moving a wobble. So, we have built mechanisms for these tasks. Currently, our robot can collect rings, launch rings, drop rings, and move a wobble. Our first mechanism we'll be discussing is the launcher mechanism. When researching the possible mechanisms, we came across the Frisbee launcher. This launcher mechanism became our inspiration for our launcher mechanism. This mechanism shoots rings through a flywheel. Our flywheel is built using a motor and a rhino wheel. Next, there's something you need to build to pave a path for the rings. For this, we use X-rails, or what GoBuilder likes to call them, Go Rails. The hardware team had to modify the build for the Frisbee launcher due to the size limit for the game. The next part of our launcher mechanism is a collector mechanism. Here we have 3D shafts with rhino wheels attached. These shafts are spun by a servo in a counterclockwise motion. The rings will go up and launch through the flywheel and into the high goal. This mechanism will be used in the driver's controlled period. For our wobble mechanism, we needed to make sure the wobble wouldn't tilt in any way. Since we needed something to make it stop from falling forward, we needed to make a mechanism that would lock onto the rim of the wobble. During our autonomous period, our robot can score points by parking accordingly to how many rings are in front of us. The number of rings in front of us can be either 0, 1, or 4 rings. This will decide where we will be able to park to score points during our autonomous period. Our last mechanism we'll be discussing today is our ring mechanism. This mechanism will end up being able to hold 2 rings to drop them during endgame. Now, originally, we thought friction would be strong enough to hold these 2 rings, but it sadly wasn't enough. We ended up hooking our first ring near the servo mount and second near the screw we have attached. Our next part that we have to do is be able to code the servo to be servo mode left, meaning that this square beam would go inside and eventually drop the 2 rings onto our wobble. That's all for our robot. We can't wait to show you guys more about our robot and Steam as well, showing you our robot in action and what materials we use to build our robot. That's all for now. Bye!